All right, says an archery target is sold with a face diameter of 60 centimeters. The radius of the center yellow ring is 6 inches. The width of each of the other rings is 6 inches. Find the probability of an arrow randomly landing in the yellow circle. Um, what are we noticing there when we read that? Yeah, we've got some issues there with units. And I don't know that when we look at the picture that is consistent with the way they typed it, right? So that's kind of a poorly written question. Um, if you totally neglected units, I think you probably get this right. If you pay attention to units, you probably get it wrong. So let's just kind of go through it and let's neglect units right now. But it says the radius of the center ring is 6 inches. The width of each of the other rings is 6 inches. Okay, so they're saying that is 6 inches right there, correct? A little red distance. Let me get a different color here. All right, so that is also 6 inches. That is also 6 inches. That is also 6 inches. And then they're saying that is 6 inches. Okay, so we've got 1, 2, 3, 4, 5 of those that are 6 inches. Does that make sense? So if there's 5 of them that are 6 inches, what is that total distance? 30 inches, which kind of collaborates with the idea that this should not say centimeters, it should say inches right here, right? Okay, so I was doing that to make sure we do have the understanding that should not be centimeters, should be inches. It says the radius of the center yellow ring is 6 inches. Okay, so what will be the area of the yellow one then? If that distance there is 6, 36 pi. Okay. It says find the probability of an arrow randomly landing in the yellow circle. Okay, well, don't I need to know what the area of the target is? And what's the area of the target going to be? (900 pi), right? It's pi r squared, but in this case, r would be that 30 inches. Okay, so 30 squared is 900. So now, area of yellow divided by target would be the probability of landing in the yellow, right? So I'm just going to write 36 over 900. What happens to the pi's? Why can I? Yeah, they cancel each other out. So 36 divided by 900 then. Okay, 0.04. Or they want it as a decimal, but if we change it to a percent, it'd be 4%, right? Okay. Let me ask this question because it is important to understand. Let's do this problem and let's see. So I'm just going to write down here. The probability yellow was 4%. Let's see what the probability of landing in the red is. Okay. So to land in the red, think about what the red circles or the red region would be. The red region would be the area of the red, if everything was red, so it'd be the area of that red circle, right? Everything there that is red. And then you remove the yellow one from that, right? Okay. So I'm going to try to figure out what that area there is. Okay. Well, the area of the red would be what we said this was. They said that this radius here was 6, right? And then the width of that ring was 6. So what is that total distance? 12. Okay, so we'd be going 144 pi as the area of the red, right? We said the area of the yellow was 36 pi, correct? Okay. So the red annulus, there, the red annulus is equal to 144 pi minus 36 pi, right? Okay. What's that? 100? Is that 108 pi? Okay. I would then divide that by 900 pi, correct? Okay. 900 pi was the whole target. So the area, or the probability, I guess, of hitting red would be 108 divided by 900. And 108 divided by 900, let's clear that, 108 divided by 900 gives me 12%, correct? Okay. So probability of red is 12%. So what are you seeing? And my question then is, as I move out and I say, okay, what's the probability of landing in the blue? What's that going to be? What do you think it's going to be in comparison to the red? You think it's going to be 36? You think it's 3 times as big? Okay. Let's try it real quick. Okay. Because we've already got, so basically what we'd be doing is taking the blue area minus this red one, right? And my thought is, if you're doing a question like this where I keep asking you, keep going further and further, you already have that red area, don't you? That red area was 144 pi, correct? Okay. So let's do probability of landing in the blue would be the blue circle, which is going to have a radius of, that would be, from there to there would be 6, there's 6 more, and there's 6 more, right? So it'd be 18. So we'll go 18 squared pi minus then, okay, because that's the area of everything from that outer. So if I look at that outer blue edge area, the circle on the inside of that, would be 18 squared pi. But I want to remove from it this red circle. So this red circle will be 144 pi, right? And I then want to divide that by 900 pi. Okay? So let's see what that looks like. 18 squared is 324, isn't it? Okay. So 324 minus 144, okay, gives me 180 pi up top. 180, 180 then divided by 900 is 0.2. Okay. So you guys did, I think people saw that there was a kind of a factor of 3 occurring here, right, between this one and that one. Okay. Now we get the probability of landing in the blue to be just 20%. Okay. So is there now a linear relationship? Linear means that from yellow to red, you have the same kind of increase that you have from red to blue. Is that linear? Okay. Okay. So percentage-wise, you're seeing that you're increasing 8% each time, right? Okay. Do we think? Well, let me, and maybe making this argument, you could look at this and do some work here. Let me see if we look at how much we have so far. If I have 4% plus 12% plus 20%, the next percentage would be what? 28. So we're thinking maybe the black would be 28% probability. And then the white you would think would be 36. If this is a true pattern, what should those things add up to? 100, and they do. Okay. So we could maybe, without having to do the black area, without doing the white area, maybe make that argument that we should know that 20% and 36% of the circle, of the entire target. Does that kind of make sense? So you can do little things like that to project and think about relationships. Let me ask you a question. So as you move out on the target, and hopefully you realize why the goal of archery is to hit the bullseye, because you have a lesser probability as you move in, a lesser and lesser chance of hitting the yellow, right? As you move out, you have greater chances of hitting the black and the white and that kind of stuff. Does that make sense, everybody? Okay. Now, there are, if you've ever like played darts or anything like that, there are like separate rules to like point accumulation and stuff like that. And I don't know what those things are, but could change then as you play the game. Probabilities may adjust and affect where you'd want to place your dart or your arrow. So then you guys said you had another question on another one of those archery questions. This one. Target with a diameter of 56 centimeters has 4 scoring zones formed by concentric circles. The diameter of the center circle is 8 centimeters. The width of each ring is 8 centimeters. A dart hits the target at a random point. Find the probability that it hit a point in the yellow. Okay. All right, so it's a pretty similar setup. All right, so everything's in centimeters here. This is correctly written. It says a diameter of 56 centimeters. So how big would that be? It'd be 28. Wouldn't it be half of 56? Okay. So the area, let's just call it the largest circle, is equal to 28 squared times pi, right? Okay. To get the yellow, do you see that you would be finding the area of the circle with that radius? How big? So it's the radius going out to, I don't know if you can see it real well because that color of blue, but it'd be the radius going out to there. How big would that be if each width is 8 centimeters? Yeah, that width right there of the yellow ring is 8 centimeters. So cut that off, and you would have that there to be a radius of 20. Okay, so that would be an area of, so we go area up to the blue circle. Okay, it would be 400 pi, wouldn't it? 20 squared times pi. Okay, so what am I going to do with those two numbers to get the yellow annulus? Yeah, area of the yellow is going to be 28 squared pi minus 400 pi. And then I'm going to divide that by what? .28 squared pi. Now, I think maybe what sometimes throws people off in this question is the fact that they got this green kind of border around here. I think that's just the background that they're using because we can't really necessarily, with any of the information given, you see that we don't know what that little distance right there is, right? There's a gap down here. Okay, so I don't think, no, actually I know that they're not trying to get you to incorporate the green. Okay, and you would just evaluate that, see what that's what you get there with that question. Now I could present you with something later on where maybe I make the yellow circle tangent to that square, and ask you some things about that. But in this case, because they're not sharing any points, you can't tell how much bigger that square is in the circle. Does that kind of make sense? So yeah. Any others on there? Those are, in the past, guys, those are the ones that are most commonly missed. Okay, Parker? Yeah, that's a good one. All right, so I try to walk you through the process here with asking you to find the area of the purple, find the area of the rectangle, and then find the probability of throwing a dart at the region and hitting the purple area, and then find the probability of hitting the white area. Okay, so because these two answers here are going to help you decipher what these probabilities down here are. Okay, so the first two are necessary. So as we look at this, hopefully finding the purple areas was not too difficult. Okay, if I want to find the area of the purple, okay, would you agree that that is 2 circles? Okay, I don't know what's going on with my projector, but the colors are all kind of messed up. It's kind of hard to see, but that says 6 right there. So that radius is 6. That radius is 6. And that radius is 6. Does that make sense? Okay. These are semicircles. Okay. So if I add those two together, I get 1 circle, right? Okay. And then add to it essentially that circle. So 1 circle would be pi r squared, or pi times 6 squared. That'd be 36 pi, right? So the area of the purple would be twice that. So the area of the purple is 72 pi. Questions on that? All right, so now here's where it gets kind of tricky, is find the area of the rectangle. And it's the reason I made these radii kind of the way I did. Because if I make them in another format, that distance is really easy for you to determine. Okay? But would you guys agree that I could take that 6 and put it right there? And then I could put it right there, correct? And then I could put it right there, correct? I keep replacing those radii. So I've got 6 there, 6 there, 6 there, 6 there. What is the length of that? Yeah, it'd be 24 would be equivalent to that distance right there, wouldn't it? Okay. Now, the number one mistake that people say is now that this distance here is 6. What is that distance there going to be? 12. It's 2 radii, okay, or the diameter of your circle. So 12. So now the area of the rectangle should be, with 24 times 12, 24 times 10 is 240, plus then another 24, 48. So 268. 24 times 12. 288. 288. Yeah. It's 48, not. Okay. So 288 is the area of that rectangle. There we go. All right. So now, if I want to know the probability of landing in the purple, it would be the probability, the likelihood of landing in the purple divided by the likelihood of landing anywhere, right? And anywhere would be the area of the rectangle. So we got 72 pi divided by 288. That would be that third question throughout the problem down there that I have to scroll to. Does that make sense? The next question is, what's the probability of landing in the white? And usually this is kind of maybe, if I didn't structure the question asking you for 3 or 4 different things, I would generally ask this question, say, find the probability of landing in the white. Because you have to go through all this stuff to get there. Does that make sense? Okay? I tried to kind of kind of ease you along in that process. So, like the ACT will say, find the problem. They'll give you this picture and say, find the probability of landing in the white. And they won't give you the 2 or 3 preliminary questions that you have to kind of solve before you can get there. Okay? Landing in the white, would that be the complement of landing in the purple? Okay? So probability of purple is, just going to evaluate this real quick, 72 pi divided by 288 is 0.785. Okay? Probability complement of purple, which is exactly the same thing as the probability of not purple, which is another way of writing this, probability that purple. Okay, remember from contrapositives and inverses that symbol there means not, or the negation. And ultimately for us, it'd be the same as probability of white, correct? So all these things say the same thing. All 4 of these things say the same thing. But when I'm looking at knowing the probability of something, and that something being landing in the purple, and I want to know what the probability of not that something is, can't I just take 1 minus that something? That's the complement idea, isn't it? Okay, so subtract that from 1, and you get 0.2146 as a decimal. Okay, now if let me check these. Rounded to 4 decimal places is kind of what we're looking for there, so that would be fine. Okay, I would want to change that 0.785 one, I think. Obviously, you'll look back what that was for 4 decimal places. Does that kind of make sense, though? All right, those are the types of questions because that I like and that I think get you to use a little bit of critical thinking, help you develop that aspect of your mind. Because they're staggered, there's a lot of parts to them, a lot of components. I would want to be able to do that one towards the middle of this week, or something very similar to that. Are there any others on here? Put that one all right? You want to talk about the parachute one? Parachutists jump from an airplane, land in a rectangular field shown. So they have to land in the field. Okay? So that gives us kind of our target. Does that make sense? Okay, our total. So what's the probability that a parachutist avoids the 2 trees represented by the circles in the diagram? Assuming the person is under low control of the landing point, so they're not skilled with this. Write your answers percentage accurate to 1 decimal place. So, a couple different things we could do here. We could find, if I want, basically what I ask is what's the probability of landing in the orange, right? Okay. Could I take the probability of landing in the orange, probability of landing in the orange, a couple different ways. We could say that is, obviously it is going to be the orange divided by the total rectangle, correct? And is the orange the same as the rectangle minus circle 1 minus circle 2? Does that kind of make sense? Okay. So we could do it that way. All right. So in that approach, we would say, okay, so the area of the rectangle would be, 100 times 80 is going to give me 8, and then how many zeros? 3 zeros. Okay. So that's the rectangle. That's going to be on top, and that's going to be on bottom. But on top, we're going to remove some stuff from it, right? We need to remove this circle. What is the area of that circle going to be? What's the radius of that circle? Yeah, it's going to be 64 pi. It's going to be the area of that circle, right? So I need to remove 64 pi from here, from the 8,000. And this one's going to be 25 pi. Okay? So if I do that, let's see here. So we're going to go 8,000 minus 64 pi minus 25 pi. And all of that's going to be divided by 8,000. Okay, so I have a, let's say, around a 1 decimal place. So 96.5% chance of missing the trees, right? 96.5%. That's one way of doing it. Okay, another way of doing it is, let's say, probability that I avoid the trees. Would that equal 1 minus the probability of hitting a tree? Does that make sense? Okay, so the probability of hitting a tree would just be the tree areas, 64 pi plus 25 pi, divided by the entire rectangular field, so 8,000, okay, and remove that from 1, right? So 1 minus that. And what I want to show you is that that is the exact same thing as what we have up here, because why? Think about this. Instead of just evaluating, let's just use some of our algebra sense. If I do this, and let's say I wanted to subtract this, those are two fractions, right? One is a fraction, and then this is a fraction, correct? Is 1 the same thing as 8,000 divided by 8,000? Minus then 64 pi plus 25 pi over 8,000. Now that I have those common denominators, can I do the work with the numerators? Now I'm subtracting a quantity, so I need to put parentheses around those things. But is that thing right there exactly the same as what we have right here in black? Is 8,000 minus the quantity of 64 pi plus 25 pi the same thing as 8,000 minus 64 pi minus 25 pi? Yeah. Okay. So 1 minus hitting the tree is the exact same thing as avoiding the tree. So you've got two approaches there. Whichever one logistically seems simpler to you is the one I hope you use. Okay. There are some situations in probability as we get further into probability, and maybe in Algebra 2 course, where finding like the probability that I avoid the trees might be impossible for you to come up with. But finding the probability of hitting the trees might be very easy for you to come up with. Okay, so in the event that they want me to find a probability that I kind of have no way of doing, I want to use the complement idea, and then I can get that probability. Okay, so it's kind of sometimes a little bit of a workaround to come up with a probability that's very, very difficult to determine. And you start learning that and dealing with that a lot more when you start dealing with what we call combinatorics. You guys have heard combinations, permutations from Algebra 1, some of you. I think Ms. Coles is working on that right now with her Algebra 1 students. In that field of mathematics, you use the complement rule quite a bit. Any others on here? Feel like we get the hang of this? It's not too bad. Okay. Hopefully you realize that it's getting you to focus and kind of rehash